Welcome. In this tutorial, we are going to learn about Dunder methods, which are also known as magic methods or the special methods. It adds new capabilities to class and it is called as a Dunder method, which is a short form. For example, double underscore str double underscore is called as a Dunder str. So let's begin with Dunder methods for string representation. They return string representation of your object. So first method is Dunder str. It represents nicely printable informal string representation which is used by print function, str function and format function as we saw for the string formatting. Second one is REPR. It is an official string representation which looks like a valid Python expression to recreate object. So whatever string written by the REPR, that representation is or can be used to recreate the same object for which we are invoking REPR method. And third one is format. It represents object into user-defined format. So in format method, user can pass the format specification that will be used to format or to represent object into the string. So with format Dunder, we can support multiple formats in which an object can be represented, and based on pattern defined for format specification, format returns different strings. So let's print an object of a user-defined class which does not implement any of this string representation Dunders. So this is a point class which has only constructor which initialize the parameters passed to it, and if we create object of this class and if we try to print it, it will print the memory address of that object. Now to print the content of object or its representation in string, we need to override string representation Dunder. So as we can see here, for class point we have defined Dunder str which returns informal string representation for object. So this is the string which will be returned when your print function is invoked on the object of this point class. Same way, REPR, it will return a string from which the original object can be constructed. So here we are storing the parameters passed to it, and this is the constructor syntax to recreate the object. So if we create an object of this class here, this should be the string returned when REPR method is called on the object, so that from that string the original object can be reconstructed. And third one is a format which takes format specification and it support this hash or pound sign f, and it replaces that character with this formatted string which represents the point object. And all of these methods returns string. So first we will create object of this point class and we will invoke different methods to get the string out of this Dunder methods. So here we have used print function, REPR and format. So let's invoke it. And this is the f string representation of this 3 method invocation. So using f string, you can invoke the same functions. So let's execute it. So as we can see here, it is returning, this is the string representation, this is REPR representation, and this is the formatted string representation. This is written as per the implementation defined inside the Dunder methods. Now, it is not required to implement all of these Dunder methods in your class. So instead of defining all, you can define only REPR, which is used as a fallback method for Dunder str. So when printing object, if your class does not define str Dunder, then it will use the string returned by the REPR Dunder. So now we will only implement REPR method inside the point class, and we will print object of the class, which will use REPR method. So as we can see here, when we are printing the object, it is also returning the same string which is written by the REPR method, which is called or which is written by the Dunder REPR. And if your class only define str method, such as here, your REPR method will not print formatted string, it will print the address of the object. So here we can see there is only Dunder str inside the class, and if we try to print REPR of that object, it will print the memory address of the object instead of printing the string representation of object. So at least implement REPR method inside the user defined class. Now we will see Dunder methods for arithmetic operations. So Dunder add allows object of your class to perform addition operation. So in this expression, the self is an object of the class which implements Dunder add, and other is an object of the class which may or may not implement the Dunder add. But when performing addition operation, whatever the attributes of the class which implements add Dunder uses, that must be present on the object other. Otherwise it will raise error. So same way, add Dunder supports expression where the first object defined other may or may not implement the Dunder add, and second is a object which implement the Dunder add, and add Dunder is the Dunder for in place operation. For example, this self plus equal to others, which is a short form of self equal to self plus other. So for all other operators, they have R reverse and I in place method for them. So same way you can perform subtraction, multiplication, division and modulus operations. So we will define point class which implements all this Dunder and will perform arithmetic operation on the object of this class. One thing here to notice is it is returning new object of the class which is a result of the operation. So when performing addition operation on two object, it will return a new object which is the result of the operation. Same way for other operations too. So let's create object of this class and perform different operations. So as we can see here, it is returning point object which is result of this operation on object P1 and P2. Now P1 and P2 are both object of point class which implements all these methods for arithmetic operations. Now we will see with object which does not implement this arithmetic Dunder methods. So here is a point which implements this Dunder method and the class point2 which does not implement any of these Dunder methods. So for arithmetic operation addition, we have defined reverse addition and in place addition. So even if the other object does not implement this operation, it will allow you to perform addition operation. Okay, and we will also perform in place operation. So here we have created O1 which is object of a class which does not implement this Dunder. Now we will perform addition operation with object. So here as we can see, O1 plus P1, it is returning point object performing the addition operation on this both object, which is only possible because the point2 class have same set of attributes in it. So when performing this operation, it is returning this new point object. Same goes for the in place operation with the other object. It is returning the result of the operation, which modifies the object itself. So whatever the result object of this operation comes, it will be stored inside the variable P1. So now P1 will point to the new object which is the result of this operation P1 plus O1. Next is Dunder for bitwise operation. So these are the bitwise operators and this is the Dunder method for it. So we will implement all this method for point class, and for all this operation they are having this reverse Dunder and in place Dunder for them. So you can support other object which may not implement this Dunder method, or you can support in place operation for these operators. So here point 1D implements this bitwise operator Dunder, and we have implemented REPR method, which represents the integer value stored inside into the binary. So we can see the result of these operations. So for all operation, we are invoking its operator inside it, and we are returning the new object. So when we are printing the result of this operation, it will be printed the REPR representation of returned object. So let's execute it. So as we can see, it is performing AND, OR, XOR, left shift and right shift operation on the given object. Same way, we can implement in place and reverse operation. So for that, this point other does not implement AND Dunder, and we want to support AND operation with this other object. So for that, we have added support for AND operation with reverse AND and in place AND. So same way, if we invoke this, it will allow this bitwise operation with other object with the same set of attributes, and also the in place operation for the object. Next is comparison operators, which returns the Boolean value based on comparison. So Dunder equal perform the comparison operation on the two objects and returns the Boolean value. If it will return true if both objects contain same value, otherwise it will return false. Same way, not equal to will return true if both objects are not equal. So we will implement all this comparison operator for the point class. So here, as we can see, we have implemented Dunder method for each operator, and it is returning Boolean value. So it will first compare the value X, and if it is equal, then it will check for value Y for each comparison operator. So as we can see, for example, for less than operation, first it will check that if X is less than the X of other object, then it will return true. If both are equal, then it will check for the Y, and based on that it will return either true or false. So all the operator Dunder method is implemented for this class point. Now we will perform comparison operator on the object of point class. So here are the three objects we have created. Out of three, P1 and P3 are containing the same value. So first we will compare P1 and P2. So equal to returns false, not equal to returns true, and based on value, so first value X is same for it, but second value Y is different. So because P1 contains larger value, it will returns true for the P1 is greater than P2. Same way it will return greater than equal to true, otherwise less than or equal to is value having false. Now with the same value, equals to return true, and less than or equal to and greater than or equal to returns true, because both are equal point. So this way we can support comparison operators for our user defined class. Now in order to support all this operation, we don't need to implement all of this comparison Dunders. We can only define equal to and less than and apply total ordering decorator on the class in order to support all this comparison operator. We will see it with example. And for equal to and not equal to operation, we only require to implement equal to Dunder. So not equal to Dunder will be implemented when we want different behavior than the opposite behavior of the equal to method. So only in that special case not equal to will be implemented. Okay. So now we will define point class, which only defines equal to n less than Dunder, and we will apply the total ordering decorator, which is imported from the func tool, and we will perform all the comparison operation on the object of this class. So same objects we have created earlier. So as we can see, it is returning the same result as we saw for the point class, which implements all the comparison Dunders. So after adding the comparison Dunders to class, the collection of objects can be sorted. So for example, class point implements the equal to and less than Dunder for comparison, and we have applied the total ordering decorator. Now it supports the comparison operators, and if we have created collection of object of point class, it can be sorted using the sorted method. So as we can see here, the list is sorted as per the comparison order defined inside the comparison Dunder. So for this class point, they are stored or they are sorted as per the order defined inside this method. So first here we are comparing the attribute X, and then we are comparing the attribute Y. So according to this order, they will be sorted. And if you want to sort in the reverse direction, you can pass reverse equal to true, which will perform reverse sort. Now each time you will perform sort operation, it will perform the sort function based on the order defined for the comparison Dunder. But in some scenario, we may want to sort a collection with a different set of attribute. For example, this student class, it defines multiple attribute for each student, and its default comparison Dunder implementation is to sort according to the roll number. But in some scenario, we may want to sort a collection of student based on their full name, which is a combination of first name and last name. So in that scenario, we can pass a custom comparison function to the key parameter to the sorted method, which will sort the collection of object based on the attributes defined inside it. So first we will sort the collection of students as per the default sorting. So the sorted will return the list of student based on their roll number. So based on default implementation, it will sort the collection based on roll number of student. So as we can see, this is the original list and this is the sorted list. Now we want to sort this collection based on their full name. So we need to define one comparator function which defines the set of attributes to be used for the comparison. So here we are returning the full name, first name plus last name. So based on whatever value written by this function for each student object, they will be compared, and the value written by it must be comparable. So here we are returning the string because first name and last name is stored as a string, and string supports the comparison operator. So it will perform comparison based on this full name. So here we are passing this comparator function as a key parameter. Now the same collection will be sorted according to this combination of first name and last name. So let's execute it. So as we can see here, it is sorted as per the full name of the student. Next is value conversion Dunder methods, which returns the converted value which is stored inside the object of the class. For example, Dunder int will return int representation of value which is stored inside the object of the class. Same for the float and boolean value. And you can also implement the built-in function support for round, truncate, floor and ceiling. So by implementing this Dunder method, round, truncate, floor and ceiling, you add support for this built-in function. So for example, point1d class implements all this Dunder method, which basically does convert the value stored inside the attribute x into float value, and it is invoking the built-in function for the float value. So now this class supports all this operation, and we can invoke these methods which are built-in Python method for the object of this class. So if we execute it, as we can see, it is returning the value as per the operation invoked on it. So it is returning int value, float value, boolean value, and it is truncating, rounding and taking floor and ceiling of the value which is stored inside it. Next is Unaray Operators Dunder method. So we can add support for unary operations such as positive, negative, invert and absolute value for the object of the class using these Dunder methods. So for point 1d, we have defined this Dunder methods which returns the new object of a class performing this given operation on the object of the class. So now when performing unary operation on the object of this point1d class, it will return an object containing the result value of the operation. For example, this object p1 is holding negative value. When invoked with the unary operator plus, it returns the object with the positive value. Same goes for the other operators. Okay, so here it is inverting the value and here is a absolute value for the object. Same way, if we check for the positive value, it will return object for the operation as it is performed on the object. So it returns the negative value when it is performing the negative operation. So next is delete Dunder. It is called when object of the class is destroyed. Okay, and it is also called when you perform delete variable. However, it is not guaranteed then when you perform delete the variable name, the object is reclaimed immediately from the memory. And for C Python implementation, object is automatically reclaimed by garbage collector when object count reaches to 0. So for example, when you are creating an object of a class and you are storing inside the variable, it increments its reference count. So when you are storing here this object will contains a reference count 1, and when you are assigning this variable to other variables such as p2 equal to p1, it will increment its reference count. Okay, and when you are performing delete operation, it decrements the reference count. So when that reference count reaches to 0, object is reclaimed. Okay, so for the point class, we have defined the delete method which will print we are deleting this object when it is reclaimed from the memory. So after creating variable p1, we are deleting it. So it will contain reference count 0 and it should be reclaimed from the memory. So as we can see here, it is printing deleting this object with this ID. And if you try to access this, it is saying that p1 is undefined because we have deleted the variable. Now we will delete a variable which is pointing to an object which is having reference count greater than 1. So we have created object point and we are assigning that reference to variable p2. Now p1 and p2 are pointing to same object and that object containing reference count equal to 2. Okay, and this is the proving that both p1 and p2 are pointing to the same object. Now when we are deleting variable p1, it will decrement the reference count of this object. Now still it is containing reference count 1 which is pointed by the variable p2, and if we check and access p2, the same object is still accessible. Now if we change the reference of p2 variable, this original point object will have reference count to 0 and it will be automatically removed from the memory. So let's assign different value to p2. So as you can see, it is printing the message we have printed inside the delete Dunder method, and that object is reclaimed from the memory. So you can perform any operation which you want to do before reclaiming this object from the memory. So if you have assigned some resources inside the init method of the class, then those resources can be freed when object is reclaimed from the memory. So that logic you can write inside this delete Dunder method, which will guarantee that this statement written inside it will get executed when the object of the class is reclaimed from the memory. Next is bytes Dunder. it returns the byte string representation of object when calling the bytes method. An object is converted to the byte representation in order to store the object onto the disk or to transmit it over the network. And with bytes dunder, a static method frombytes is defined which recreates an object from its byte representation. So to support the bytes representation to an object of your class, bytes dunder is defined. So for this point class, we have defined bytes dunder which returns the bytes value of the object. So we are returning byte string when this dunder is called, and we are encoding the byte string into UTF-8. And we have defined one static method frombytes which will take this bytes representation as an input, and we will convert this representation into a point object. So we are extracting this value. So first we are removing this braces, and then we are extracting the value of class and its attribute, and we are checking that the class is point. Then we are creating object of this class and returning it. So this way we have added support for the bytes. Now the object of this class can be converted into the bytes or reconstruct the object from the bytes. So let's perform the same operation. So here we can see first we will check the type of the P1, which is a object of a point class. Then we have invoked the bytes method here, as you can see. So the object is converted into the bytes, and the same bytes is passed to the frombytes method, which will return the point object which is converted into the bytes. Okay, so here it will be the object which is containing the same value as this, and if we check the type of this object written by frombytes, it is the object of the same class. Next is Dunder hash. It returns the int value for the hashable objects. Python uses hash function to store and retrieve object in a data structure which uses hash table such as set and dictionary, and hash dunder is generally implemented for the immutable objects. Now we will see what is the difference between id and hash function. So id returns the same value for the variable which are pointing to the same object in the memory, whereas hash function may return the same value for the two different objects which are stored in a different location in the memory. So both objects may contain different value. Although they are holding different value, their hash value may be the same. So that is the main difference between id and hash function. Now if we try to use an object of the class which does not implement hash dunder inside one of the data structure which uses hash table such as set, it will give you type error. So here we are trying to store our object of point class which does not implement hash dunder into the set. So it is saying that type error, unhashable type point. Now in order to add support for it, we need to implement hash method. So before implementing hash, we will understand the contract between equal to and hash method. So hash function should return the same value when it is called repeatedly on the same object. Okay, so the reference of object might be assigned to the different variable, but when it is invoked on a same object, it must return same hash value when it is called repeatedly. And when equal to method returns true for two objects, both objects must return the same hash value. And hash function may return same value for two objects for which equal to returns false. It is called as a hash collision, and data structure which uses hash generally implements hash collision resolution strategies for that. So these three contracts must be specified or must be met when we are implementing the hash function with the equal to Dunder. Now we will see the parameters of default implementation of hash function for the Python. So system.hashInfo returns the parameters of the hash function which is used by the Python. So these are all the attributes and their value. So which algorithm is used, width of the bits used for the hash value, the modulus value which is used for calculating hash, and so on. So you can use default implementation or you can implement your own hash function. We will use this default implementation in order to calculate hash value for our user-defined class. And all the built-in data structure which are immutable, such as string, tuple object, implements this hash dunder. So we will utilize their default implementation in order to support hashing in our user-defined class. So for our class point, we have defined hash value, hash function, which returns the hash value retrieved from the tuple object. Because this tuple object containing the values of attribute x and y are stored in the tuple object, and x and y are immutable because we are storing int value in it, and we are taking hash of that immutable tuple object containing immutable values. So we are guaranteeing that we are returning the hash value which satisfies the contract we saw earlier. Okay, and here is the equals method which compares all the attributes before returning true and false, which are used to calculate hash value. So whenever the equal to returns true, this hash function will return the same value. So this satisfies the hash and equal to contract. Now if we create object of this point class and store those object inside the one of the data structure set or dictionary, it will be allowed. So first we will see the value of hash function for this user defined object. So as we can see, for the same object containing same value, So here we are constructing two different objects with the same value, and if we check the hash value, it is returning the same hash value. So it is satisfying the equal to and hash contract. Now we are checking the value equals to and hash value. So both are returning true and both are equal. Now if we try to create set of this point object, then it is allowed. And if we print point set, as you can see, it is storing the point object inside the set. Now this same point object can be used as a key to the dictionary data structure. Now for inheritance, if the child class overrides the equal to and needs to retain the hash dunder from its parent class, you can copy that hash dunder from the parent class using the parent class name dot hash. So you don't need to redefine exact same method from the parent, or you don't need to copy that implementation. So just write this, it will copy that implementation. And if subclass does not override equal dunder and does not want object of class to be hashable, then just set hash dunder equal to null. So none will set object of the class as a unhashable. And by default, the hash dunder value of a string and bytes are salted with an unpredictable random value to provide protection against a denial of service. Next is call dunder. So using dunder call, we can make object of the class callable. For example, class point implements dunder call, which will be called when you are calling object. Okay, this is something new to the programmers who are coming from the other languages such as Java or C. So object of the class can be called in Python if they are implementing this call dunder. And whatever the parameter passed to it, we can pass it here as a argument. So in order to perform certain event handling on the object, you can specify this dunder call. So if we invoke it, as we can see here, it is printing the message we have written inside the call dunder. Okay, so you can write your business logic here, which will get invoked when your object of the class is called. Next is Dunder methods for the class with the collection of objects. It enables the access to an individual object. So Dunder len will return the length of the collection. Dunder get item with given key returns the item with the matching key or an item with which is stored at the given index. Set item adds or modify the value which is stored with the given key or the value which is stored at the given index. And delete item deletes an item with the given key or an item which is stored at the particular given index. So for example, first we will see a class with the collection of objects stored in a key value pair. So this example, we have defined two classes. First one is a student and second one is a class. Class contains a constructor which stores collection of student object stored inside the dictionary object. So it is a key value pair data structure, and to allow access to an individual student, we are implementing this Dunder methods for the access to the collection of the object which are stored inside the class. Okay. So without implementing these methods, object of your user defined class cannot be accessed same as we saw for the dictionary object. Now after implementing these methods, you can use object of the class same as we used a dictionary object class. Okay. So this way we can access collection of object. So here we have created students. So student class defines hash dunder, so it is hashable, so we can store it inside the set or the dictionary key. But here we have used the roll number which contains int value, and we are storing the students as per the roll number here. So when we are accessing an object with the roll number key, this get item dunder will be invoked, and it is returning an item with the given key from the dictionary stored inside it. Same way, set item we will pass the roll number and the student class object. So it will store a new entry or modify the entry with the given roll number and student object. And same way, if we pass roll number, it will remove entry with the given roll number from the dictionary object which is stored inside the class. Okay. So same dictionary object is passed to the constructor of a class. Now after creating class, we can use any of this method to access individual objects. So first we will take the length of the class. So it is returning 5 because it is holding 5 students. Same way, as we have accessed the dictionary entry, if we try to invoke on the object of class with a given roll number, so it is printing the message we have wrote inside the get item method. So it is fetching student and it is returning the student with the given roll number from the dictionary. Same way, we can add new student. So it will print the message written inside set item, and if you are accessing a new student, as you can see, the new student is added, and if you are deleting, it will print the deleting message, and as we can see, length of the class is decremented by 1. Same way, if we are using index data structure inside our user defined class, such as this class is storing collection of student into the list, so we can allow access to an individual student using the index. Okay, so when getting the item, we are passing the index. Same way, when setting item, we are providing index as a key, and whatever the value provided, it will be stored at the given index. And when we are deleting it, we are using index to delete a particular item. So we have created class. Same way, length will work the same way as we saw earlier. It will return the length of the collection. Now when you are adding a particular student, we are using append method of list. Okay, so it will create a new entry into the list. Now if you are accessing that particular new entry using index, so as we can see here, the newly added student is fetched using index. And same way, you can use index to delete a particular item stored at the given index. So it will remove a value at given index. Now after removing it, if you try to access that particular list, as we can see, the particular student with roll number 1054 was stored at index 3 is removed. Next is missing Dunder. When key is not found, this missing Dunder is implicitly invoked by getItemDunder. So default implementation for getItem is to invoke missing method when the given key is not found. Okay, and if you are overriding this getItem, or you are defining getItem to your user defined class, you need to manually call this Dunder if you are using it. Otherwise it will not trigger. Now in order to use this, we will use the same example of class and student, but instead of using a dictionary, we are inheriting, or we are extending the user dictionary class, so that we don't need to explicitly define getItem, setItem and deleteItem method inside our class. So this is the recommended way if you are using a class which stores the collection of object. We will see in detail in upcoming session. Okay, so we have extended this user dictionary class which has this get, set and delete item, and we are overriding the missing method. Now this Dunder will call when you are trying to access an object with the key which is not present in the collection. Okay, so this implementation will check whether the type of key provided is a string. If it is a string, then it will convert that string into the integer and try to look up again on the dictionary object. Okay, so by default, if you are using int key, if you are trying to look up the same object with the string key, it will give you key error. But using this missing Dunder, we are adding support for providing a key as a string, and we are just putting a warning message that you try to access using int key, and if the int equivalent value of a given string is valid, it will return the object stored with the given key. Okay, so here we have created a class with the collection of student. Okay, so class object is created. Now we are accessing a student with the roll number 101 given as a string, which does not exist inside this collection. But using missing method, it will convert this key given as a string into the integer and it will return the object. So as we can see here, it is printing the warning message, so which means it is calling this method, and it is returning the object with the equivalent int value of a given key. So you can also define your custom business logic when an invalid key is accessed. Next topic is shallow copy versus deep copy. So shallow copy creates new object with collection by copying the reference of object of the collection from the original object. And when you are creating deep copy, it creates new object with collection by copying all of the object of the collection recursively from the original object. So depending on the requirement, you can use either shallow copy or the deep copy. So we will see the example in which we will see how it copies the reference or creates the new object when we are using the deep copy. So for that, we have created three classes. So shape contains collection of points and drawing contains the collection of shapes. Okay, now three layers of collection we are storing. Okay, so first we are creating collection of point into the two shapes, and two shapes are stored inside the drawing, and using this we will perform shallow copy and deep copy, and we will compare the objects which are stored inside the drawing object with the copy of the drawing object. So here is the original drawing object, and here we are creating a shallow copy using copy.copy function. Okay, so shallow copy is created. Now first we will check the ID of the both of the object. So both are the different object. So the copy of the object on which you are performing copy, it will create a new object of the given object. So that two objects are different. But if we will compare the ID of the inner object of that copy object, it will be the same as the original object. So now we know the object composition. Here drawing stores the shapes. Okay, so now we will compare the shapes of both the objects, original object and the copy object. So if we check the ID of it, as you can see, both the attribute are pointing to the same object. So no new object is created. It has just copied the memory reference which is stored inside this shape attribute into the copy object. Same way, if we traverse further, so shape contains points. So for the first shape, if we access the collection of points and check its ID, they are also pointing to the same object. So the point objects which are stored inside the shape also pointing to the same objects. Now we will create the deep copy. So using copy.deepCopy function, we will create a deep copy of the object. Now we will compare the same objects. So outer object, its inner object shape, and the third hierarchy level object point, which is even stored inside the shape. So if we compare, so this is the outer object is different, same as we saw for the copy. But if we compare shapes, it is pointing at the different object, and even further, if we go to the point which are stored inside shape, they are also copied recursively. Okay, so now you know how the copy and deep copy performs. So when you are using deep copy, it will copy recursively all of the object composition, all the object hierarchy you have stored inside the given object. Okay. Now here, as we can see, we haven't implemented actually the copy and the deep copy Dunder method inside our class. So this is the by default behavior of copy and deep copy. But when you are using a large object, you may not want all object to be copied when you are using deep copy, or you may want to modify the behavior of a shallow copy. Then you can override this Dunder method for copy and deep copy in order to customize the behavior. And this memory dictionary attribute is used for storing and IDs of the objects which are already copied when you are recursively copying the objects. Okay. Next topic is monkey patching. So modifying class or the module definition at the runtime is known as a monkey patching. So after creating a class definition, if you are modifying this class or the module, it is known as a monkey patching. So using it, we can add Dunder methods in order to enhance the capability of a class. For example, this class point does not define the string Dunder method. Now in order to support it, we can define a method and we can write a string Dunder method implementation inside it, and we can assign or we can create this Dunder str attribute and assign this method to it in order to support the string operation on the existing point class. So after this, if you are printing the object of this class, it will print the string representation defined inside this method. So let's execute and see. So as we can see, so earlier we know it is not containing any string representation method, but using monkey patching we have added support for the Dunder str so that it can be printed in a string representation. Okay. So that brings us to end of the video.